So here is our second practice problem, part of optimization under Calculus grade 12. It says the profit WX earned by a company to manufacture X bicycles per week is given by. We have WX is equal to negative X cubed over 150 plus 3X squared minus 250X minus 2,700. What should the weekly bicycle production be to maximize profit? So here we have this equation. Let's understand what this is. This equation WX represents the profit, where in this equation, wherever we have X, X is how many bicycles are produced per week. Now we are concerned with maximizing profit. And I mentioned to you guys in the previous video that whenever they ask you for maximum or minimum, please think of local maximum and local minimum from your cubic functions. And think of how you would get those. So we follow the same method here. Since we're trying to maximize, think of calculating your local maximum. We would get the first derivative, equate to 0, and solve for x. That is exactly what we are going to do here. Now, we want to get the first derivative of wx, so we're going to call it w prime x. The first derivative, well, our first term, we're going to take the exponent, multiply with the coefficient. Remember, your coefficient here is 1 over 150, well, actually negative 1 over 150. That becomes negative 3 over 150. Yes, you can simplify. Your calculator may give you negative 1 over 50, which is perfectly fine. We can actually write that. Negative 1 over 150. And the x cubed becomes x squared. For the second term, we get plus 6x, and the third term is negative 250. The last term, negative 2,700, falls away. Now, once we have our first derivative, we will take that first derivative and equate to 0. So we have w prime x equals 0. Taking that whole equation, equating it to 0, and we basically want to solve for x here. So here's what I'm going to do. I don't like this 50 in the denominator. I'm going to multiply throughout by that 50 so as to get rid of it. Doing so, that is going to give me, actually, let's multiply throughout by negative 50 so that we can get the first term to be positive. Doing so, that is going to give us x squared minus 300x plus 12,500 equals 0. Now I know this is a bit, the values are a bit too big for you to factorize, so go ahead, use your quadratic formula. I'll leave that for you guys to do. I'm just going to give you the x values here. Once you use your quadratic formula, and remember, you would need to show a method, so please make sure you do that. You should have x is equal to 250 or x is equal to 50. Now here's the thing, we have two values. And remember, x in this question represents bicycle production per week. So this says that either they can produce 50 bicycles or they can produce 250 bicycles. But we are concerned with the bicycles that makes maximum profit. At this point in time, we don't know. It could be 50 bicycles that gives them maximum profit, or it could be 250. But obviously, we have to use a calculation to show this. Now, you guys, since we are following the steps that we do when calculating the local maximum, once we have our x values, the next step is to take those x values and substitute into the cubic function, into the original equation to give you y. So we're going to take each of these values and substitute into our equation for w. So let's calculate w of 250. And since w represents profit, whichever value gives us the bigger profit, then that is how many bicycles need to be produced per week so that we can maximize the profit. Okay, I'm first just working with the 250. Now, I'm just doing this here to show you guys what your substitution should look like. In your equation, wherever you have x, you are substituting 250. Now, since W represents profit and profit is going to be in rands, this is the value that I have, 18,133.33. Let's now try W of 50. So let's now see what the profit is if only 50 bicycles are produced per week. So we're going to do a similar calculation. Now we're just substituting 50 wherever we have x in the original equation, Wx. Okay, let's just correct that. Sorry, that is 50. So you guys, something weird goes on here. We get a negative value and we do not want a negative profit in any business. So obviously, producing 50 bicycles per week actually puts them into a loss. So between 50 and 250, the bicycles that gives them the maximum profit is 250 bicycles. So now we can conclude and say, therefore, let's say maximum profit is obtained when 250 bicycles are produced per week. Okay, so we don't just stop at our x values. We must take those x values and substitute so that we can see what the maximum profit is, since that was what the question asked, okay? They didn't just say the number of bicycles, but rather they wanted to know what the maximum profit is going to be. So which number of bicycles produces the maximum profit? So that ends this question. We are done.